Everyone, good morning. My name is Madison Swain-Bowden. My pronouns are she, her, and I'm going to be talking today about Airflow and how you can make managing your workflows as easy as breathing. A little bit of background on myself. That's me and my wife and our cat and our dog. We live in Seattle, North Seattle here. And I am a data engineer by trade. I've worked as a data engineer at the Allen Institute for Cell Science here in Seattle, at Ookla, which is the company behind speedtest.net and Down Detector. And then also at, I'm currently a sponsored maintainer of the open source project Openverse, which is a search engine for openly licensed media. So a little bit of an outline of what I'm going to be talking about today. I'm going to give a brief summary and history of what Airflow is. I'm going to talk about why I'm giving this talk. And then I'm going to showcase some real use cases of Airflow that I have encountered in the last 7 years that I've been interacting with Airflow. I'm going to give a very brief comparison to some other tools that are similar workflow management engines. And then lastly, I'm going to show what Airflow looks like and talk about how to get started. So to start off with, what is Airflow? Who here has used Airflow before? Okay, cool. Who here has heard of Airflow before? Okay, great. Very cool, very cool. So what's all the hot air about Airflow? Airflow is an open source workflow management platform. That sounds very buzzwordy, but one way to imagine Airflow is to think of it as cron on steroids. So if you're familiar with cron, cron is like a scheduling program that's available on most Unix systems. And Airflow is a scheduler for more complex workflows, but it's really supercharged in a number of ways that I'm going to talk about today. I'm going to use the term DAG a lot. DAG stands for Directed Acyclic Graph. If any of you have used Git before, you're actually already familiar with DAGs because the Git commit history is a DAG itself. But that's how Airflow thinks about workflows. This has those directed acyclic graphs. And lastly, the most important part of Airflow, which is what has made it stick with me at least the last 7 years and across several different positions, is the fact that Airflow, everything you do in Airflow is in Python. And that really becomes a superpower for being able to write these workflows. A little history of Airflow. Airflow started as a project at Airbnb in 2014 to manage their machine learning pipelines. They open sourced the project in 2015, and then it came under the Apache Incubator umbrella in 2016, which just means that they were making sure that the project was stable, and that they could support it, and then it officially came under the Apache Software Foundation in 2019. If you're not familiar with the Apache Software Foundation, that's fine. My point in bringing this up is that Airflow has a longer history in terms of software that's been around, and it's also the stewardship by Apache means that it has stable maintainership. So even as an open source project, the fact that Apache is backing this means that it has stable maintainers and will continue to have a stable direction for the project. Okay, why am I giving this talk? Which is a great question to ask several minutes into the talk. I'm really passionate about Airflow. I'm a contributor, but I'm not sponsored by Airflow to give this talk. But I just really like Airflow, in part because, and as you're going to see today, it's applicable across a variety of circumstances. I believe that if you're interacting with data in some sense, then, or in some way, as a data analyst or a machine learning scientist, there are things that you're going to want to schedule or workflows that you're going to want to run. And knowing a little bit about Airflow can really help augment that data-related role, even if you're not a data engineer, full-time. It's also a great open source contribution entry point. And I mean that as a twofold thing. The first being Airflow itself is open source, and they're always welcoming new contributions. I just this last month contributed something to Airflow upstream. But on top of that, if you're familiar with the structure of Airflow and how Airflow works, then you can actually go and contribute to other projects that use Airflow. And as you can see by the next bullet point, it's a lot of different things. So Openverse, the open source project that I'm sponsored to maintain, uses Airflow. And so even if you don't know the domain in which Airflow is being applied or know the specifics about the domain knowledge, having knowing what Airflow is and how it works can help you contribute to those spaces too. And as I said in the last one here, it's used all over the place, behind the scenes. I mean, places like Adobe, Disney, a bunch of social media sites like Tumblr and Reddit, NASA JPL, lots of companies use it. So I say this because I think it's a worthwhile investment to at least be a little bit familiar with a tool like Airflow. Airflow kind of follows the Python model of being batteries included. So you get out of the box with Airflow a lot of things, namely a web UI, which I'll show off a little bit later, automatic retries, right? If you have a finicky task that's part of this larger set of this larger workflow, you can just set retries on that task and it will work just fine. Flow control, things like, okay, this task can skip if a condition is not met or if a condition is met. This task should only run if this other task fails, that sort of thing, get that out of the box. Passing data between tasks. In Airflow, passing between tasks is as easy as returning from a Python function. And then, yeah, you can hand data really easily between totally disparate actions. You get rate limiting, so you can say, like, this is a really intensive task and I only want 4 of them to run at once. Task queues, so you have a GPU-specific task that has to go on nodes that have GPUs. You can set that up in Airflow. Secrets handling for connections, connections to various systems. You can do runtime configuration changes, meaning that you don't have to push a new commit to main in order to have something change in the way that a DAG is run. Integration with like dozens, probably hundreds of systems like AWS, different Google Cloud platforms, Salesforce, all sorts of integrations. Dynamic workflow generation. I'm going to talk about this a lot, but this has really changed the way that I think about workflows in the sense of being able to have one workflow configuration or one workflow definition and then a bunch of configurations, and just have Airflow take both of those and make all of the workflows that we needed to run. Dataset-based scheduling. So we have, maybe a trigger-based scheduling where I say, okay, I have these conditions that I want to run. I want to clean up some data on the database, so I'm going to run this workflow with these parameters. We also have time-based scheduling. I have a job that I want to run weekly or daily. Airflow also has data set-based scheduling. So you can say, I want this workflow to run whenever this file is available in S3. And then you don't have to worry about writing the logic to check if the file is there and then skip the rest of the workflow, right? You just say, when this is ready, run this, and Airflow will take care of the rest. And then lastly, for those of us who have to deal with service level agreements, there's also SLA monitoring that comes out of the box. So that's a lot, but this is like all that you just get from spinning up Airflow. Next, I'm going to go through a couple of use cases of how I've used Airflow over the last 7 years, or again, how I learned to stop worrying and love the DAG. The first I'm going to talk about is at the Allen Institute for Cell Science. So this was a stem cell research institute here in Seattle. And we took these 3D images of cells, and then we're able to segment or pull out the information from the cells to create a 3D model of the cell. That process, though, is very difficult. So this is actually a slide deck from 6 years ago. It's really multi-step, very hands-on, very okay, this scientist generates a CSV and hands it to this scientist, and then this other scientist who has this information can run a batch job on all of the images that are produced, and maybe some of the images are failed, and maybe we have to rerun those. There's a lot of problems with this kind of workflow. Emailing of CSVs, some of these CSVs are huge, 4.5 gigabytes, right? It's really very difficult. And so what we were able to do is encapsulate that workflow in Airflow. And so all the scientists had to do was acquire the images and then upload them to our server, and then Airflow would take care of managing all of the processing that needed to occur on those images. And what we got out of that was very hands-off, right? We didn't have to have multiple different teams involved in that. One image failing didn't mean that we had the entire batch processing fail. Images could get into the system as soon as they were ready, rather than as a batch process. And it was just, it certainly gave me peace of mind. So at Ookla, which again, if you've run a speed test, then you probably interacted with Ookla data. We used Airflow there for a number of things. I actually gave a talk about our usage at Airflow Summit in 2021. The Airflow instance that I was in charge of was replicating data from our write-heavy database to our read-heavy database. And so the write-heavy database was for results coming in, and the read-heavy was for analytics. So we had a couple of different policies for how we copied data or replicated data from the write-heavy database to the read-heavy database. So 3 different pipeline types. And what Airflow let us do is convert. We had one job for each of these tables, right? And we had hundreds of tables. So if we needed to make a change to the logic in that workflow, then we had to go and edit hundreds of JSON files that described each of these different workflows. And what Airflow allowed us to do, because it's defined in Python, is write the workflow once for each of these 3 types. So we had 3 different workflows, and then use, if anyone's familiar, Python data classes to define the different tables that we were using. And then we just iterate over all of those configurations in a for loop and say, Airflow, here's the workflows, and it produced hundreds of workflows for us. And that way, if we wanted to change the logic, we only had to change it in one place, and it was affected all of the related workflows. We also used it for reporting. So running reports on our database, right? Running a query and then aggregating that and sending a message out. Data consistency checks, so checking that certain columns had certain data types or didn't have certain data values. And then we also used it to orchestrate data packaging for consumers, so bundling our data and getting it ready to deliver to consumers. As I said, I'm currently working on Openverse, and Openverse is a search engine for openly licensed media. You can think about it as like Google Images, but with attribution. And with Openverse, we aggregate and index data across a whole number of providers. So different providers that we have, things like Flickr, the WordPress photo directory, Stocks Now. And similarly, what Airflow lets us do is define all the machinery around interacting with the API. So the only part that we have to be concerned with when adding a new provider is the logic for converting the API's data format into our data format. And then we have the workflow already written, so we can just go off and write the logic that we care about and then add it to the configuration list. And I think if I'm lucky here, yeah. So I won't show you the actual logic for this ingestion, but what we're looking at right now is the data classes that define the ingestion procedure. And so here, you can see we have some different providers that are here, and maybe we have little configuration differences that we're providing for each one. But we don't have to rewrite any of the logic for the actual workflow. Some other things that we use Airflow for at Openverse is data cleaning. So we have a kind of an older data set, and sometimes we find some issues that are present in the data. And so we have a workflow that we use to just specify a set of parameters and how to go about cleaning the data, and then it goes off and cleans the data for us. So we don't have to keep a connection to Postgres open, on our computer or something. We can just have Airflow handle it. We also use it for infrastructure maintenance. So we have a staging database that we replace once a month, and Airflow is able to handle all of that for us. We have health checks that run on certain services, on top of some other health checks that we have. Because it's Python, because we're very imaginative, we use it for things like team automation. So this is an open source project, and we have a bunch of sponsored maintainers. And so we use it for, we have a DAG that is a pull request review reminder that uses some logic based on labels to ping certain maintainers. And then lastly, we use it for experimentation. So we have an Elasticsearch cluster, and sometimes we want to modify or experiment with search, but again, that's a long, involved process with creating a new index and whatnot. And so we've set up some DAGs to be able to do that indexing for us based on some parameters. You can just kick that off when we want to do that experimentation. The last example that I'll give is an open source tech collective for liberation that I'm a part of called Orca Collective. And so we had some desire to automate some stuff, and I thought, hey, why not use Airflow? And so with the Orca Collective, we use it for things like deploying services. When a service is ready, we just kick off the DAG that goes and deploys it. At one point, we ran a Mastodon server, and so rested on an instance. And so we were able to have Airflow manage some maintenance-y tasks with regards to that. So this person, I have this quote from this person, if the only tool you have is Airflow, it's tempting to treat everything as if it were a multi-step, optionally scheduled workload. Which I have this here because I have people come to me all the time and say, oh, we have this thing that we want to do on a regular basis or whatnot, and my first response is always, oh, well, we should just put that in Airflow. I'm going to show just some comparisons to some other, I don't know if anyone's familiar with Jenkins or GitHub Actions or Luigi, but these are sort of the workflow automation platforms that I think about. I won't get too much into this for the sake of time, but some of the big things are listed on here. One is local testing. I love GitHub Actions because it integrates with GitHub, but I hate GitHub Actions because I can't test anything. And with Airflow, you can spin up the entire stack locally and test your DAG before you deploy it, and there's some real power there. And then the multiple scheduling options. The data set-driven scheduling is really powerful with Airflow. And the dynamic workflow generation, of course, too. That piece that I said, haven't found that anywhere else as a first-class feature. Okay, so I said there was a web UI, and I kind of want to show off the web UI because it's always interesting to see how these tools are used. So this is Airflow. We have our list of workflows. This is the Airflow for Openverse. We have our list of workflows here. You can see Airflow gives us a wealth of information here, including the how frequently these are scheduled, when the next scheduled run is supposed to be, which runs have succeeded and which ones have failed. We can filter by different things. I'm going to just take a look at this. Oops. Okay, fingers crossed. Okay. And here we have a view of the run history. We get run duration. We can see what the actual dependency graph for this DAG looks like. And we can see where the current steps are, what step comes before the other one. We also get logs. So if you're printing anything from Python, then that just comes in as the form of logs. And like I said, you can pass stuff between tasks, and that comes up in the form of XCOMs is what they're called. But this is what this function returned, and that's being passed as something that can be used by downstream tasks. So that's a pretty straightforward DAG. I'm going to show you one of our more complex DAGs that's actually running right now. This is our data replication pipeline. And you might say, oh, yeah, here we go, collapse these all. You might say, Madison, wow, that looks so simple. Now, just you wait. So, so Airflow also lets you group certain tasks together. And so, we have this one task that's just do the data refresh. Well, actually, it looks like the data refresh has a lot more involved in it. And we, have this very complex set of dependencies, but the way that this is defined in Python is really simple. And you just say this task before this task, and then Airflow will figure out all of this stuff for you. Then I had talked about triggering some of the other DAGs. One thing that we can do, or one thing that we have, this is our data cleaning DAG. Airflow lets you specify all this this documentation that's available for when you go and trigger a DAG. And it also lets you specify parameters with certain types, different boundaries, different help text. And so I always forget certain things, and so it's so helpful to be able to have this. And this is all just Python code that defines this, and then you can go run it. And then lastly, because this just comes out of the box, Airflow gives us a bunch of information about what tasks are running, what pools are available, what service is healthy, et cetera, et cetera. Okay, so I'm sure you're chomping at the bit to try this out. Airflow's documentation is actually really good. It's really, really good. It looks very snazzy. It has a wealth of information. Highly recommend it. Don't try writing this down. Just Google Airflow documentation, and it will be there. There's a number of different installation methods that you can use for Airflow. The one I recommend is Docker. So Airflow has a Docker Compose template that they have defined, and you can just download that and then spin up the entire stack. And there's DAGs that are example DAGs that are available that you can play around with. And it's really straightforward. And show one other example. So that data refresh DAG that I was showing, this is the configuration for that. And we have the workflow itself defined elsewhere, but if we wanted to add a new data type that we were replicating, then we would just add this here, and we have all of that other logic present in another file. And that's it. Any questions? Go ahead.
That was great. I have a couple questions. One, does anything within the workflow has to be consistent so that it makes sense the time that you put to set up a workflow with Airflow? I'm trying to understand how much time it takes to set up a workflow. What if that workflow is just happening once? There's nothing that needs to be repeated.
Right. Airflow does excel for the case of, this is something that we're going to be running on a regular basis. But in many of the cases that I've used it, we've also used it as a one-off scenario. So that add license, the first add that I showed off is one that we're going to run once and then be done with it. And part of the reason why we're doing that is because Airflow is managing the set of steps that we have to take. And so we, as maintainers, don't have to leave our computer on to run these different things, or have to communicate with the rest of the team where a certain process is, even though it is a one-off process. So anyone on the team can go and check in on the status of this one-off thing that's running. We also have the last DAG that I showed was the bash update DAG, and I bring that up just because with that, that's a data correction DAG where each workflow that we're running is its entire is unrelated to the actual DAG. Meaning, we're trying to fix something of the data, and so we could have a separate DAG for each one of those things. But instead, the way that we've written it, we have a common workflow that we're using that goes and does the correction for us. And because of that, we get retries. We get error monitoring out of the box. And so if you're doing something maybe on your own, just with one individual, it might not be as useful. But certainly, as you start to get more collaborators involved, it's also a really helpful communication tool of here's where we're at in the process, And one thing I find, sorry to keep going, when I run a Postgres query, and then I don't get timing information on it because I forgot to turn timing information on it, I'm always so upset with myself. And so being able to not only have to worry about I have to leave this connection, I have to leave my computer on overnight while this thing runs. Airflow is also recording everything. And so I don't have to worry about how long was this duration or I missed this piece.
The second question I have is, maybe you answered some of that, but I'm curious about some platforms like Snowflake or Databricks. I have not used them, so I'm wondering if they need a great deal of workflow management as well. So maybe they have a great overlap with what Airflow is doing, but maybe because you already said that if you're just an individual working on a specific, maybe that doesn't make sense.
Well, as I understand it, I haven't used Snowflake or Databricks, so I can't speak greatly to that. But Airflow kind of sits at a level above Snowflake and Databricks because of its versatility, right? So both Snowflake and Databricks are primarily involved in, as I understand it, data and data analytics, reporting and ingestion and whatnot. But because Airflow is just Python, it can handle everything else. So say you want to run a Snowflake job or something, you can manage that with Airflow, and then have another task that runs after it, which emails a different team and says, hey, your Snowflake data set is ready, or what have you. So and I'm sure that Snowflake and Databricks sort of have their own workflows that are part of that you can call out from Airflow. But I definitely conceptually imagine Airflow is sitting above that in terms of managing anything else that needs to happen on top of that.
Thank you.
Okay, go ahead.
Is it all cloud-based, or do you have to have an enterprise server, if you're sharing flows with multiple people, how does that work?
So for Openverse, we have, all of the workflows are defined in Python, and we have a Docker Compose stack that we use. And so every individual can run the stack themselves and like run some of the DAGs locally. For our production instance, that is out in the cloud. But at the Allen Institute, we also ran Airflow like on premises. And so we had an on-prem instance of Airflow that we were running. And so it can be either. Both Google, GCP, and AWS have like managed Airflow, and Astronomer as well have managed Airflows that you can use so that you don't have to worry about setting Airflow up. I will say, historically, Airflow has been very complicated to set up. It's much easier with Docker, and it's much easier with a managed platform. But yeah, does that answer your question?
Mm-hmm.
Go ahead.
Are you familiar with Flight?
Flight?
Yeah.
No. Sorry.
How would you compare it to the
I have not heard about Flight, but I will look into it. If it's comparable to Airflow, I'm always intrigued. Like Prefect was also another competitor with Airflow that came out a few years ago. But I think I'm out of time. Okay, all right, I'll hand it over, but I'll be around for questions if you have any.